Hi everyone, good morning. So today it is the third session and the last session in the series of 3 sessions of marathon for 12th maths boards. So let's begin without wasting any time. In this session, since exam is tomorrow, I would be dealing with questions quickly so that we can cover more in less time. So basically I would be sharing important steps with you and I would leave calculation to you. Anyway, the file would be shared. The file has solutions. So I believe that would serve your purpose best. So good morning everyone. Hi. Let's begin. So in first 2 sessions we had done these topics, and in today's session these are the topics that we are going to cover. All right. So we are starting with vectors in 3D, and this is the first question. Find the shortest distance between the following pair of skew lines, and the equations of lines have been given. So quite easy, I suppose. Yeah. All right. So basically 2 points on respective lines. I am saying A, which is 1, 2, -1, and a point on second line is -2, 3, 0. All right. And vector parallel to the first line is, I am saying, say m1 vector, which is 2i cap minus 3j cap plus 4k cap. Here important thing to note is it is 2 minus y by 3. So I'll see this as y minus 2 by minus 3. All right. And the second parallel vector is -1, 2, -1i cap plus 2j cap plus 3k cap. So we know how to find the shortest distance between pair of skew lines. My answer would be, if I say D is my answer would be AB vector dot m1 vector cross m2 vector divided by magnitude of m1 vector cross m2 vector. All right. So this can be calculated, and I leave the calculation part to you. So basically m1 vector cross m2 vector, for explanation's sake, this vector is perpendicular to both the lines. So the shortest distance would lie along the perpendicular line, along a line which would be perpendicular to both these lines. So that's it. Any doubt? So let's move ahead. So these are the typical questions that you may find in boards. This was a typical 4-mark question. Next question. If the 3 given vectors are coplanar, then we have been asked the value of this expression. All right. Think about it. Basically, when 3 vectors are coplanar, then their box product would be 0. All right. So using this concept, I can say determinant A 1 1 1, B 1 1 1, C, this will be 0. Alright, so now I can solve this determinant and try to get this expression so that I can find its value. So what will I do? I'll try to make zeros. So R2 goes to R2 minus R1 and R3 goes to R3 minus R1. So what will I get? I'll get A 1 1, 1 minus A, 1 minus A, B minus 1 0, 0, C minus 1. Alright. So if I expand this, what will I get? I can expand along any row or column. Let's expand along the first column. So what will I get? A multiplied by B minus 1, C minus 1, plus 1 minus A multiplied by, here 1 minus A I can take common in these two terms. So 1 minus A multiplied by 1 minus B plus 1 minus C, 1 minus B plus 1 minus C. This is equal to 0. Alright, and what is the expression value of which we want? This is the expression. So I'll divide by 1 minus A, 1 minus B, 1 minus C. So dividing by 1 minus A, 1 minus B, 1 minus C, what do I get? A by 1 minus A plus 1 by 1 minus C plus 1 by 1 minus B equal to 0. Now this term I can write as A minus 1 plus 1 by 1 minus A, which is effectively 1 by 1 minus A minus 1 plus 1 by 1 minus C plus 1 by 1 minus B equal to 0. So the expression 1 by 1 minus A plus 1 by 1 minus B plus 1 by 1 minus C is equal to 1. That's it. And 1 is our answer. Alright. Coming to this question. 3 vectors, 3 unit vectors have been given. They follow these equations: A vector dot B vector equal to A vector dot C vector equal to 0. And the angle between B vector and C vector is pi by 6. And we have been asked to prove this. This is a typical 6-mark question that is asked in boards. Alright. So how to proceed? This is, we have to prove A vector equal to plus minus 2 times B vector cross C vector, and we have to prove the box product of A vector plus B vector, B vector plus C vector, C vector plus A vector is equal to plus minus 1. So since A vector dot B vector and A vector dot C vector equal to 0, that means A vector is perpendicular to both B vector and C vector. So I can say A vector equal to lambda times B vector cross C vector. Now if I consider the magnitude of both the sides, mod A vector, or rather magnitude of A vector equal to mod lambda into magnitude of B vector cross C vector. Now since A vector, B vector and C vector are unit vectors and angle between B vector and C vector is pi by 6, so we get 1 equal to mod lambda. B vector cross C vector magnitude would be what? Magnitude of B vector multiply by magnitude of C vector, multiply by sine theta, where theta is the angle between B vector and C vector, which is 5/6. So this would essentially be half, because B vector and C vector are unit vectors. So lambda, mod lambda equal to 2, which means lambda equal to plus minus 2. So hence we have proved the first part. Now to prove the second part, we can say, it can be derived also, A vector plus B vector, B vector plus C vector, C vector plus A vector. The box of this is basically equal to 2 times box of A vector, B vector, C vector. Alright, this can be derived simply using the formula. This basically would be A vector plus B vector cross B vector plus C vector whole dot C vector plus A vector, and we can get this. So basically this is equal to 2 times A vector dot B vector cross C vector, and we know that B vector cross C vector is plus minus half times A vector. So this is 2 times A vector dot plus minus half times A vector, and A vector dot A vector is 1. Why? Because A vector is a unit vector. So this is equal to basically plus minus 1. Hence we have proved. Alright, let's move ahead. So this is again a typical 6-mark question. We have been asked to find distance of this point. So position vector of the point has been given 3i cap minus 2j cap plus k cap from this plane 3x plus y minus z plus 2 equal to 0, measured parallel to the line. Equation of line has been given, x minus 1 by 2 equal to y plus 2 by minus 3 equal to z minus 1 by 1. Also we have been asked to find the foot of the perpendicular from the given point upon the given plane. Alright. So how do we proceed? Since we have been asked to find the distance of a given point from a given plane parallel to a given line, so I would consider a point lying on plane, lying on given plane, which if joined with this given point is parallel to this line. This is what we need, right? And then we can find the distance between this point and the point that we find, right? So let that point be A. Then since we are moving parallel to this line, say we moved lambda times this vector which is parallel to this given line. So this becomes, the point would become 3 plus 2 lambda, 3 plus 2 lambda, comma, minus 2 minus 3 lambda, comma, 1 plus lambda. Right? Now this point lies on this plane. So this should satisfy this equation. So what do we do? 3 times 3 plus 2 lambda plus 3 lambda plus 2, and I can take minus outside, minus lambda plus 1 plus 2 equal to 0. So what value of lambda do we get? 6. 2 lambda. Equal to minus 8. That means lambda equal to minus 4. Alright. So basically we are going along this vector 2i cap minus 3j cap plus k cap in reverse direction 4 times. So Now anyway you have this point A. Either you can find distance between this point A, lambda is known, so point A is known, distance between A and given point is my answer. Or you can even think logically, I have gone 4 times in reverse direction of this vector, so the distance actually I have covered while moving from given point to this point A is my answer, is the distance that we require. So this basically means -4 mod of -4, that is mod lambda times the magnitude of this vector, 2i cap minus 3j cap plus k cap, and this should be my answer, plus k cap. So this is equal to 4 root 14. So this basically should be my answer. Let's check the answer. 4 root 14 units. All right, that's it. Now we have been asked to find foot of perpendicular from the given point upon the given plane. Again, the foot of perpendicular would lie along a line from this point or passing through this point, along a line which is perpendicular to this plane or which is parallel to the normal vector to this plane. So normal vector to this plane is 3i cap plus j cap minus k cap. So normal vector is 3i cap plus j cap minus k cap. Yeah, all right. So I can assume the point which is foot of the perpendicular to be, say it to be B. It can be, and what is the point? 3 minus 2 1. The point under consideration is 3 minus 2 1. So I can assume the foot of the perpendicular to be 3 plus 3 mu minus 2 plus mu comma 1 minus mu. All right, this is plus actually. All right, so this point lies on the plane, so it should satisfy the plane's equation. That's it. So basically it would be 3 times 3 plus 3 mu plus mu minus 2 minus 1 minus mu plus 2 equal to 0. All right, this is anyway breaking, should come back. All right, so what would it be? 11 mu equal to minus 8. So mu becomes minus 8 by 11. All right, so basically put the value of mu, and this is the foot of perpendicular. That's it. All right, let's move ahead. Minus 8 by 11 is the value of mu, so we have got it right. Then just put and we get the foot of the perpendicular. Now coming to the next topic, relations and functions. So this is a typical problem. So I have taken certain questions which students are not generally taught in coaching classes, and likewise so that they can be helped to deal with boards. All right, so function has been defined from whole numbers to whole numbers. So this is the definition of the function, and we have to show that this function f is invertible. Also, we have been asked to find the inverse of function. So this is a typical 4-mark question. So one way to do this is we show that f is 1 1 and onto. All right, so that would mean that indeed inverse of f exists, and then we can find the inverse of f. All right, so if I consider this function, fn is n minus 1 when n is odd, and n plus 1 when n is even, right? So what values would f take here in this part of the definition? When n is 1, fn is 0. When n is 3, because n should be odd, fn is 2. When n is 5, fn is 4, so on and so forth. So all even whole numbers. Coming to this, when n is 1, when n is 0, n should be even. When n is 0, 0 is allowed because domain is whole numbers. When n is 0, I get fn to be 1. When n is 2, I get fn to be 3. When n is 4, I get fn to be 5, so on and so forth. So all odd whole numbers. So we see that all whole numbers are getting covered, and fn is indeed 1 1. So that means fn is invertible, right? So that can be commented. Similarly, to find the inverse, what do we generally do? If y equal to fx, we try to transform it as x equal to gy, and this is inverse of fx. All right. So same we are going to do here. Let's say m equal to fn. All right, so case 1, when n is odd and when n is even. All right, so when n is odd, fn is n minus 1, and when n is even, fn is n plus 1. All right, so that means when n is odd, that means m is even. All right, so n is equal to m plus 1, and here when n is even, m is odd because m equal to n plus 1, so n equal to m minus 1. All right, so here I can say by similar way that the inverse, if I say it as f inverse m, all right, is equal to m plus 1 when m is even, and m minus 1 when m is odd. All right, and interestingly, this is the same as the definition of fn. So basically inverse of f is f itself. So we are done with it. All right, let's go to next question, and this is a way you can write in other way. All right, and the method I used is one way, this is another way. All right, here this is another typical question. Show that the relation R in the set n cross n defined by this way, defined this way, is an equivalence relation. We have to prove this relation to be equivalence relation. So basically we have to prove that this relation is symmetric reflexive and transitive. Alright, so simple question, it is a typical 4-mark question. So what can be done? First, let's prove that this is reflexive. That means to prove that A comma B are A comma B holds. Alright, so this would be what? A square plus B square, A square plus B square equal to B square plus C square. So B square plus here A square, B square plus A square. So this holds. So hence my relation is reflexive. Alright. Similarly, if I have to prove that it is symmetric, what I have to prove is A comma B related to C comma D is equal to, I have to prove C comma D related to A comma B. That would mean that the relation is symmetric. So A comma B related to C comma D is A square plus D square equal to B square plus C square, and I can write this as C square plus B square equal to D square plus A square. So this is basically what? C comma D, or we can write as A square plus D square. Alright, no issues. Alright, so this becomes C comma D related to A comma B. Alright. So A square plus D square equal to B square plus C square. That's it. Now moving ahead, to prove that it is transitive, that is to prove that the relation is transitive. So this means A comma B, if A comma B is related to C comma D and C comma D is related to E comma F, we have to prove A comma B is related to E comma F. Alright. So this first thing means what? A square plus D square equal to B square plus C square. And the second thing means what? C square plus F square equal to D square plus E square. Now if I add both these equations, left side to left side, right side to right side, what do I get? A square plus D square plus C square plus F square equal to B square plus C square plus D square plus E square. So we see that C square plus D square cancels out. So basically this is A square plus F square equal to E square plus B square. So I can say A comma B is related to E comma F. Alright. A square plus F square is equal to B square plus E square. So hence proved. Alright. So hence the relation is equivalence relation. Let's move to the next question. Determine whether the operation, this star defined on rational numbers, is binary operation or not, and check whether it is commutative or associative or both, and also to check whether identity element exists or not, and if it exists, then we have to find the inverse of elements in rational numbers. All right. So how do we do it? Basically, I can say that if A and B are rational numbers, then A star B, which is AB plus 1, is also a rational number. A and B are rational numbers, so AB will be rational number plus 1. 1 is rational number. So this whole expression would become rational number. All right. So that's it. That means it is a binary operation. Now to check whether it is commutative or associative or both, we just have to check whether A star B equal to B star A. So that would anyway be, why? Because A star B would be AB plus 1 and B star A would be BA plus 1. So both are equal. Hence it is commutative. And to check whether it is associative, A star B star C, we have to check whether it is same as A star B star C, and you can expand and you would find that it is not associative. So I am skipping the calculation part, which based on certain comments students may find boring. All right, so this is it. And to know whether an identity element exists or not, what we essentially say, identity element is E. So we are in search of A star E being equal to A, right? And since this operation is commutative, A star E is same as E star A. All right. So A star E is what? AE plus 1 equal to A. So E would be what? E would be A minus 1 by A. Now this E depends on A. So there is no identity element as such corresponding to this operation. So no identity element, and hence no inverse exists. Hence no inverse as such can be defined. All right, let's move ahead. This is the typical way you should write. Now coming to our final topic, continuity, differentiability and applications. So we have to find derivative of this f of e to the power 10x with respect to x at x equal to pi by 4, and we have been given this one more information, that f dash e is equal to 5. So this is a typical 1 mark question, and it is important. Generally students make mistakes here. When I have been asked d by dx of f e to the power 10x, so this is basically d by dx, or rather I should write f prime e to the power 10x into d e to the power 10x by dx, or rather d by dx of e to the power 10x at x equal to pi by 4. All right. So what is it? When I put x equal to pi by 4, this becomes f prime e, which is 5, and d by dx of e to the power 10x is basically e to the power 10x sec square x. to be evaluated at x equal to pi by 4. So this is a typical question where students generally do mistakes. Alright, so this is e to the power 1, it becomes e, and this is sec square pi by 4, which would be 2. So it is tan. Alright, let's move ahead. Now the sides of an equilateral triangle are increasing at the rate of 2 centimeter per second. Find the rate at which its area increases when side is 10 centimeter long. Again, it is a simple question. How do we do it? Basically, area is root 3 by 4 x square, where x is side of equilateral triangle. So dA by dt is equal to root 3 by 4 2x dx by dt. So here x is 10 and dx by dt is 2. So I would get 10 root 3 centimeter square per second. So that would be my answer. Alright, if the following function is differentiable at x equal to 2, then find the values of a and b. This is another typical question, very simple question, but it is generally asked at boards level. So basically, since it is differentiable at x equal to 2, it is continuous also, and we have to find these the values of a and b. Alright. So first, to ensure continuity at x equal to 2, fx is 4. So that means the right hand limit should also be 4 at x equal to 2. So right hand limit will be limit x tending to 2 plus ax plus b, which is basically 2a plus b, which should be equal to f2, 4. And since it is differentiable, left hand derivative should be equal to right hand derivative. Alright, so basically left hand derivative should be equal to right hand derivative, which essentially means limit h tending to 0 2 minus h whole square fx minus f2, which is 4, divided by 2 minus h minus 2 should be equal to limit h tending to 0 fx minus f2 by 4 by this h. Alright, so basically this becomes 4 and minus 4 cancel out. So basically it becomes 2 minus h, limit h tending to 0 equal to 2a plus b is anyway 4, so it cancels out. Alright, so ah divided by h, so h is what we have got, right? Sorry, a is what we have got, ah by h. So this becomes a. So basically a is equal to 2. Alright, and since a equal to 2, alright, see here we get actually 4 square. So this is basically 4 minus 4h by minus h. So 4 it would become, and this is minus h. So a is basically 4. So since a is 4, we get b as minus 4. So that's it, b is minus 4. Alright. Next question. Now these are the typical questions that you are going to face, that you are likely to face in boards exams. This is let y equal to log x to the power x plus this x to the power x cos x and we have been asked to find dy by dx. So basically, without wasting unnecessary time on calculation, what you have to do is you take this as u, this as v, and dy by dx is equal to du by dx plus dv by dx. All right, and you can use logarithmic differentiation to evaluate these, and the solution has been provided and it would be shared with you. Simple. All right, so this is an important question that is generally asked in boards. So from boards point of view, it is important, and you have to ensure that there is no calculation mistake. All right, let's move ahead. It is again a typical 4-mark question. If x equal to a sin pt and y equal to b cos pt, then we have been asked to find d square y by dx square at t equal to 0. So parametric differentiation, basically dy by dx is equal to dy by dt divided by dx by dt. So this becomes what? ap cos pt divided by minus bp sin pt. So basically it becomes minus a by b cot pt. All right. Okay, we have kind of reversed it. So basically this becomes ulta. This is minus bp sin pt divided by ap cos pt. All right, so it becomes minus b by a tan pt. Now the important point here is, if I am calling it y prime, what I have been asked is d by dx of y prime. So this is basically d by dt of this expression y prime divided by dx by dt. Generally students forget to do this dx by dt. All right, so this is what is required. So this becomes minus b by a sec square pt into p divided by dx by dt is ap cos pt. So at t equal to 0, this becomes 1, this becomes 1, p would cancel out, and it becomes minus b by a square at t equal to 0. All right. All right, so this is what the answer is. Now this is again a typical question at boards level. Some function is given and it has been told that Rolle's theorem holds in 1 to 3, this range, with c being this. So we have been asked to find the values of a and b. All right, so basically it means f1 equal to f3 and f prime c, which is basically f prime x at x equal to c is equal to 0. So use these two equations to get values of a and b. So this question I have included so that you are aware what kind of questions, especially those who have been focused only on coaching and JEE stuff, so you can know these are the typical questions that come in boards. All right, so this is the typical solution. Again, a typical question, 6-mark question. Find intervals in which this given function, which is x minus 1 cube into x plus 2 whole square, is increasing, is strictly increasing or strictly decreasing, and we have been asked to find points of local maximum and local minimum. So I would go for first derivative. So first derivative will be what? X minus 1 square x plus 2 multiplied by 2x minus 2 plus 3x plus 6, 5x plus 4. Alright, so this is first derivative. Now if it is positive, then the function is strictly increasing. If it is negative, then the function is strictly decreasing, and accordingly we can find local maximum and local minimum. So for f prime x to be positive or negative, we will have to use this real number line. So this becomes 1 minus 4 by 5 minus 2. So plus, so you can present this in tabular form also, which is anyway shared with you. So you can see like this, since it is a square, even power minus plus. So basically function is increasing in, or strictly increasing in, minus infinity to minus 2 union minus 4 by 5 to 1 union 1 to infinity. Alright, and function is strictly decreasing for minus 2 to minus 4 by 5. Alright. Now we have been asked to find local maximum and local minimum points if they exist. Then basically what does it mean? The function is decreasing, the function is increasing in minus infinity to minus 2 range. So basically it would be like this, and minus 2 it will be like maximum, because again from minus 2 to minus 4 by 5 it is decreasing, kind of like this, and then minus 4 by 5 to 1 it is increasing, and again at 1 the derivative is 0 and again it is increasing. So typical curve would be like this, rough sketch. So I can infer that I would get maximum here and minimum, local minimum here. So local maximum would occur at minus 2 and local minimum would occur at minus 4 by 5. That's it, and that can be found out, and that can be reasoned in language, using language. So that's it. The same has been reasoned here. It has been expressed in tabular form, which you may not be able to see now. It would be anyway shared, and that's it. So it says minus 4 by 5 is point of local minimum and minus 2 of local maximum, and this is what we have got: local maximum, local minimum. Simple, right? So this is another typical question related to maximum minima. A farmer wants to construct a circular ground and a square ground, and the sum of their parameters should be 600 meter, and we want to prove, or we have been asked to prove, that sum of their area is least, is minimum, when the side of square garden is double the radius of the circular garden. And do you think that a good planning can save energy, time, money? That is like, kind of subjective explanation kind of thing, you have to comment. So basically from mathematical point of view, we have to say the side of a square, if I take it as x, and radius of circular garden, if I take it as r. So I have to prove that area, which I am saying as A, is minimum when x equal to 2r. This I have to prove. Alright, and I have been given that parameters, that means 4x plus 2 pi r equal to 600, and my area would be pi r square plus x square. So basically I can write area to be equal to pi r square plus x square. I can write as 600 minus 2 pi r by 4 whole square. So this A is a function of R. What will I do? I'll do dA by dr equal to 0. And I would get the value of R, and then I will show that actually at that value of R, d square A by dr square is positive. So that I can show that actually at that value of R, I am getting a local minimum of A. Alright. And then since R has been got, I can find X, and we would be able to conclude that X is indeed equal to 2R when the area is minimum. So I am not going into calculation part to save time. It is to show you that these are the typical question. This is a typical good question, so-called good question at boards level. So you should be able to solve it, and this is how you should show properly with proper language and all. Alright, so this is how you should present. This would be shared with you, and yeah, this is how it is. And last question of today, find dy by dx if y is equal to e to the power sin square x multiplied by 2 tan inverse under root 1 minus x by 1 plus x. So here this part is interesting. Alright, and you can either directly differentiate it, or you can simplify this part and then differentiate it. Alright, so this is the takeaway for this problem, and this is again a typical problem that you may be asked in boards. Alright, so to resolve this, what will I do? 1 minus x by 1 plus x. So 1 minus x, 1 plus x, this kind of expression is coming. So I can take x as cos 2 theta. Alright, and to ensure that cos 2 theta is taking all values minus 1 to 1, I can say 2 theta belongs to minus pi. Alright, 0 to pi. I can say 2 theta belongs to 0 to pi. So minus 1 to 1, all values have been allowed, and that means theta belongs to 0 to pi by 2. So under root 1 minus x by 1 plus x is under root 1 minus cos 2 theta divided by 1 plus cos 2 theta. That means under root 2 sin square theta divided by 2 cos square theta. 2 would get cancelled, and since theta lies in first quadrant, theta actually belongs to 0 close to pi by 2 closed. Alright, so sin square theta and cos square theta both would be actually sin theta and cos theta both would be positive, and I can simply take them out as sin theta by cos theta, which is tan theta. Alright, so basically x should not be minus 1, so that means it should not be pi. Alright, like this it can be reasoned out. Alright, and so it should not be pi by 2. It should not be pi by 2. So basically theta will not be pi by 2. So cos theta is not getting 0, is not becoming 0, and same way in original expression also cos 2 theta, which is x, is not becoming minus 1. So 1 plus x is not becoming 0 since it is coming in denominator. That's it. So basically this expression 2 tan inverse under root 1 minus x by 1 plus x is basically 2 tan inverse tan theta, which is basically theta lies from 0 close to pi by 2 open. So this tan inverse tan theta would be theta, so it becomes 2 theta. Alright, so this whole expression 2 tan inverse under root 1 minus x by 1 plus x has been resolved to 2 theta, and 2 theta is basically cos inverse x. So basically my expression becomes y is equal to e to the power sin square x multiply by multiply by cos inverse x. Alright, that's it. And now you can differentiate y with respect to x. You can again use logarithmic differentiation if you want, or you can do it directly, and I leave this to you. It's not the main takeaway of this question. You can solve it, and that's it. This is the typical way you should write. And thank you. Have a nice day. So I hope this series helped you. I have discussed some relevant questions with their solutions and how to present them at boards level. All the best for your upcoming maths boards exams. Thank you. Bye. Complete or?